Hey guy, alright, so I was supposed to lecture this in class yesterday, but as you know, many of my sophomores were not in class due to your high school exit exam. So here I am recording this for all of you. Alright, so just in case that you don't, just in case that you're not here, then at least you can listen to this and get your homework done. So from the example the day before with finding the force, okay, remember the day before we were working on an example of finding the magnitude of the force that's gonna help, that's gonna keep my kids from rolling down the hill. So from that example, we're gonna add on to it, okay? The work done, okay, so the work W, done by a constant force, which is represented by F, in moving an object from point A to point B is defined as, okay? So let's talk about a point A and point B. So here's A. It doesn't have to be at the origin. Here's B, okay? So I want to find how much work, okay, do I need to move something from here to here, okay? So we're going to assume force, which is represented by vector F, is applied along the line of motion. Let's try the word motion up here. Okay, so if this is, for example, let's try to find something. Okay, let's talk about like a 4-year-old, which is my kids, right? So if my kid is trying to push a chair, okay, so here's a chair at my house. Usually they're pushing the chair this way, okay? Now, because they're only 4, so their height is about the height of the chair, so they're really just pushing, their arms are right this direction. So we're going this direction and they're pushing this direction. So that's why this is the force, it's applied, okay, along the line, okay, so straight line of the chair moving, okay, or the movement of the chair. So we're going to say that the work, but we're going to find the work, okay? So work, which is represented by W, equals the magnitude of force, okay? So the work equals the magnitude of force times the distance, okay? So it's going to be represented by a big W equals magnitude of force times distance of AB, okay? And distance of segment AB, so here's segment AB, distance, okay? We can find it using the magnitude as well. So that's if we're moving in the same direction as this object. Now what if the object's way too tall, okay? So you want to move this cabinet this way, horizontally this way, but because look at this guy, right? He's not really, this is not a smart way of moving, obviously. Usually you want to push sort of right here. So he's aiming at this particular angle, okay? So this angle is a theta. We don't know what that is, okay? So if the constant force, okay, so his force is not along the line of motion. So the motion is this way, okay? He's a little bit short, so he's pushing it up and over a little bit. So the excuse me. So the force is not along the line motion, okay? So we're going to go this way, but he's kind of pushing it up a little bit, but instead at an angle theta to the direction of the motion. So we have slightly a different formula. So we want to find the work again, which is represented by W, equals amount of force. Let's put this in the direction of segment AB, okay? So amount of force, and we're going to do the dot product of the distance of how far we're moving, okay, which is segment AB. So formula wise, we're going to go W represents work equals, okay, the dot product of these two. Okay, dot product of the force and the dot product of your AB. Alright, so let's do an example and see which one we're talking about. The girl in the picture below is pulling a wagon, right? With a force of 50 pounds. How much work is done in moving the wagon 100 feet from the handle? That makes 30 degrees with the ground. Okay, so obviously she's taller than the wagon itself. So the handle is not going flat. Okay, so her arms is all the way up here. So it's forming an angle of 30 degrees. This is your theta. So let's talk about what theta is. Theta is 30 degrees. Okay, we want to move, okay, from a point to, let's start here. We're going to start at 0, 0. This is where we are starting, and we want to move it 100 feet later. So if you have let's call this A and let's call this B. Okay, so this right here is your A to B, your distance A to B. Now, this force is forming a 30 degrees angle with the ground. Okay, so this is your force. So this vector equals, to find the vector, we're going to need the magnitude of the force times cosine of some angle times vector I plus sine of some angle times vector j. This is just a formula to find any vector in its position, right? In the standard position, which is starting at 0, 0. So this force has a magnitude of 50 pounds. So vector F equals 50 pounds times cosine, theta is 30 degrees, or alpha is 30 degrees in my case, times I plus sine of 30 degrees times j vector. So this force equals 50 cosine of 30 degrees is going to be rad 3 over 2 I plus sine of 30 degrees is 1/2 j. Let's simplify this out a little bit. Okay, so this is going to give me 25 rad 3 I plus distribute your 50, so that's be 25j. So this is the force vector. Alright, so we found the force vector. Now we're going to use the work formula, because it says here how much work is done in moving this particular object, in this case a wagon, 100 feet from where we started. So because it's not in the direction of the object, we're going to use this second formula right here, which is, I'm going to write on the bottom, the work equals the dot product of the force and the dot product of the distance, okay? The distance vector, which is, let's call it A to B. So with that said, it's A sub 1 times A sub 2 plus B sub 1 times B sub 2. This is going to give me, my A sub 1 is going to be this one, 25 rad 3. 25 rad 3. A sub 2, oh, we never wrote an equation for this one. Okay, vector AB equals, there's no vertical, so we are not going to have any J element in here, but we do have 100 units this way to the right, so the positive 100i. Okay, so this is my vector for this. Okay, so I have 100. That's my A sub 1, A sub 2 plus B sub 1 is going to be 25. B sub 2, I don't have any I, so that's going to say 0. So this is going to be 2500 rad 3. Okay, let's see what that is in decimals. Okay, so here we go. 2500 times rad 3. Oops. That's going to give me about 4,330.13. And the unit of measurement for work. Okay, there are two types of unit of measurement. In physics, you guys probably, especially if you're in physics, you have joules, right? Now for our particular one, we're talking about pounds, and we're moving in this direction in probably feet. Okay, so we're going to move about 4,330.13 pounds every foot. So the unit of measurement is foot pounds. I know. It sounds really funny, especially if you've never done a work problem before. But this is sort of, think about it as like if you're driving in like miles per hour. So this is really how much you need to move each foot. Okay. So this child is going to need to move that many pounds per each foot. Okay. And that is the end of our 9.5. So your goal today is to finish copying this notes and then do assignment number 15. Okay, so let me just write it right here for you. Homework number 15. Okay, section 9.5, number 10, 20, 25 to 28, and 30. This is all going to be due on Thursday.